Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 5 a.m. on Saturday in London. We're broadcasting live from Thousand Oaks, California.
Tonight, Pam will be talking about science magic. We'll be back in 8.3 seconds. Can you perform science magic at home? Remember a time in science class when the instructor poured liquid nitrogen across the floor? Perhaps they added pure sodium to water to show you what happens. Or maybe you saw a demonstration of someone sticking a rose in a dewar of liquid nitrogen and then whacking it on the table where it burst into pieces.
Let's get some comments.
So Cliff.
Go ahead and show them. Thanks for joining us, people.
Hey, Cliff, you're actually on your own computer this time. Scott, hey, Scott.
Welcome, welcome.
And hi, Dawn.
Hey, Dawn. Glad you're all here.
So tell us about science magic, Pam.
When is magic real? When it's science magic. Even a techno-mage uses science. In my book, Your Amazing Itty Bitty Explore Space Now book, I highlight 15 simple activities you can do from home. And science magic certainly qualifies. Magic can draw us in, and for me, the pull has been getting a bit stronger lately. Some inspiring incidents. Oh, hi, Jeannie.
Hi, Janie.
Yeah, hot Friday night. When I was young, my grandfather took a regular banana out of the fruit bowl, and he went abracadabra and cut it
with his hand.
In 3 pieces, and then when he peeled it open, it was in 3 pieces. It was like abracadabra, and there it was, and it blew me away. How did he do that? In a classroom when I was also young, a teacher had 99 cc's of a clear liquid in one very tall beaker. These were really tall. And 99 cc's of a clear liquid in another tall beaker, and then poured one into the other, and it came up to 100 cc's. How was that possible? Well, we dug around and we found a video about it. You want to run that?
Sure.
Thanks.
Oh, there we go.
All right, everyone, welcome back to Cody's Lab. So I have here a bottle with some water in it. To this, I'm going to add some 91% isopropyl alcohol. I'm going to be demonstrating molecular packing, and so I will show you the volume of the liquid before and after mixing it. This is a common demonstration that I've seen in my chemistry class, but I want to try doing it with the lid on the bottle. Now that I have the lid on, I'm going to slowly turn it over to show you that there is no air bubbles currently in the bottle. If you look closely, you can see the alcohol is floating on top of the water. Despite its higher molecular weight, isopropanol is less dense than water. Now watch as I give the bottle a good shake and mix the two fluids. As you can see, a large bubble forms. And the funny thing about this bubble is it's not an air bubble. It's actually a vacuum. There's nothing there. And if this bottle was a metal drum, it would have actually crushed it. My hypothesis as to why this happens is that the alcohol molecules, which are large, have spaces in between them that the smaller water molecules can fill. And sugar molecules are about the same size as the alcohol molecules. So let's go ahead and try this with honey. As you can see, I've added some hot water on top of some honey, and that there's no bubbles in the jar. Give this a good shake to dissolve the honey into the hot water, and let's see what happens. You can see that there's some bubbles already forming, indicating that some space has been removed. And as you can see, after shaking it for some time, that it actually does form a nice big bubble. Sugar doesn't really react with water, and it didn't generate any extra space. Basically, I've just consolidated the spaces that were already there. Spaces that were too small for air to get into. But now when I open the lid, air is able to go into this larger void. And as you can see, the foam gets squished by the sudden increase in pressure. Now I'm going to show this on a more macroscopic scale with some hazelnuts and rice. Give these a good shake to mix them well. And now you can see the volume is significantly reduced as the rice filled the spaces between the hazelnuts. Hope you guys enjoyed. I'll see you next time.
So bring us back. Pretty cool, huh?
Yeah, in fact, I really liked the rice and the hazelnuts to show basically what's happening there.
Absolutely, I did too. So the teacher in my class added water to the alcohol, and it only came up to 100 cc's instead of the, presumed or hypothesized 198. Did we have a comment?
Oh.
Yeah, it fits in between the water molecules.
Yep.
Right. We actually, go ahead and share again because there was a nice article that Jeff found for me.
Okay. And before I do that,
yeah,
you're talking about, pouring the liquid nitrogen across the floor.
Yes.
I didn't witness this, but someone else in my high school did.
Yeah.
A new science teacher decided to do that.
Uh-oh.
Unfortunately, we had stick-on foot 12-inch vinyl tiles on the floor.
Oh.
And it froze the glue and it popped the tiles off.
Yep, I can believe that.
Okay, so
you can go ahead and pull. Yeah, there you go. Because this actually talks about it in terms of a liquid lattices. So this chemical concept demonstrates spaces between particles in a solution, liquid lattices, and polarity. And they actually have pictures of 500 milliliters of each poured together, only comes up to 970. And they give you a nice explanation of this. Both of these are polar. As such, they create intermolecular lattices, arranging themselves on the basis of the charges they carry in hydrogen bonding. So, pretty interesting stuff. Go ahead and bring us back.
Okay.
And so, yeah, we actually came across this other video kind of recently called an Ames window. So let me set that up and go ahead and share that one.
Okay.
It's kind of short, so we'll come back in 1.5 minutes.
And we'll let it go. Now you know that it's turning around in circles. In fact, if you look at it from above, you can see that it's turning around in a circle. But now your brain is doing something strange. It's telling you that it's not going around in a circle, but it's oscillating. In other words, it's turning part way, stopping, and then going back the other way. Now that's a strange effect, isn't it? But if you think that's strange, wait till I add something through the middle. What am I going to add? Well, I'm going to add a ballpoint pen. And to do that, I've placed a little piece of double-sided sticky tape on the ballpoint pen. You can use ordinary sticky tape if you like. I'll place it right through the center of the window and press it in place like that. Now this time, by fixing on the pen, you will be able to see that the pen is going around in a circle and not going backwards and forwards. But what's your brain going to tell you about the window? Will your brain allow you to see the window going around in a circle with the pen? Or are you going to see something really strange? Well, have a look at that. That's unbelievable, isn't it? You can see the pen going around in a circle, but your brain is telling you that the window is going part way around and turning and going the other way. And yet in order to do that, the two things have to pass through one another, the pen and the window. You know it's not possible. You know it can't happen. And yet as you look at it, you see them going through one another every time they go around. An amazing illusion, the Ames window. And I think you're going to have a lot of fun making your own.
So
there we are. Now,
oops.
Whichever way you...
Oh, I got to stop that one. Sorry. Yeah, there are some pretty interesting illusions out there. So let me get back to, yeah, there are like some magical relationships such as, I think of them as magical. 1 cubic centimeter of water is 1 milliliter of water. And if it's water, it weighs 1 gram. Yeah, amazing.
Yeah. Well, I mean, to me, that one's not magical because they basically set 1 cc of water to equal 1 gram of water and called that a milliliter.
The gram weight. Whatever else, it's a gram. It's the weight of 1 cc of water.
Yeah. Well, basically, they just basically picked them all to basically be there.
Yes, I think it's kind of magical. And even water is kind of interesting because unlike almost everything else, when water is frozen, it expands.
Yeah, the most common form of ice.
Yeah, so, I mean, everything, all these other things will, when they heat up, they expand. When they cool down, they contract, but not water. I think there's some other interesting things about water too.
Right.
I didn't write them down. I thought we would discuss them. Can you remember about?
Well, for one thing, when water freezes, it actually forms a matrix, and
Okay.
and
So
when it
crystalline.
melts, when it melts, those matrices kind of go away, and the atoms can get closer to each other. In fact, even the various atoms of the water molecules actually disassociate in that water. It's actually a soup of oxygen and hydrogen.
Okay.
So that's why it's so good at dissolving stuff, and it's also why it's so chemically reactive.
Okay. So a quick trick, and perhaps you saw this as well recently. The last time my computer did an update, the Firefox browser let me know that there's an icon to simplify the page that you're reading. Go ahead and share the screen, Jeff. We got a comment?
Yeah.
Excellent.
Cliff says, I was really good at chemistry in high school, and the show with the window is from Towards 2000 Science Show in Australia. I watched it, seems like 100 years ago. Yep.
Not quite 100.
Yeah.
So go ahead and share the screen, Jeff, and that icon is right up here. And so when you push on it, you will get this. It'll simplify it. It'll get rid of the various ads. I think you can lose some pictures, but it's not too bad. There's a picture there, and there's some really cool science tricks here. But I want to go over here, and Scott had a comment. I see that.
Okay. I wonder if heavy water ice acts the same as regular water ice. For the most part, yes, Scott.
That's a good question.
It does not act this. Yeah, heavy water doesn't act quite the same chemically as regular water, simply because the hydrogens are heavier and thus have more inertia, I guess you would call it, and they're harder to move into or out of the water molecule. So chemically, it's not as active as regular water, which means that, yes, my thought for giving everyone heavy water on a spaceship so that you can just use it for fusion or not means that you kill everyone. So no, can't do that.
No.
And Cliff started as Towards 2000 and then Beyond 2000. Yeah, I used to watch the show Beyond 2000, Cliff.
I see.
And
interesting. I thought you were talking about time frame. Okay, so it was the name of the show. Got it.
And I had a buddy in college from Australia who said something about Australia not being beyond 1900, but
Ouch.
He said it much better than I did, but
so I do want to kind of stray just a little bit, because we've heard this abracadabra for a long time, but I think that it actually kind of an interesting thing happened in the Harry Potter books. They actually came up with this Avada Kedavra, also known as the killing curse. And let me just read a little bit of this to you, because there's something magical, pun intended, about how J.K. Rowling constructed her Wizarding World, aka the Harry Potter universe. A part of the reason why it feels so real is that she used real life terms and meanings behind the magic. For instance, one of the most well-known curses, Avada Kedavra, has a meaning in real life. So what does Avada Kedavra mean? In fact, Avada Kedavra! And we go to a simplified version. Yay, I can actually read this without the ads. Let's see. It has a much... Nope. Back up.
Yeah, the old Aramaic phrase.
There it is. It's an old Aramaic phrase that means let the thing be killed. It was used as a spell originally to cure illnesses. The thing being destroyed was the illness. It's also highly likely that the phrase was the origin of abracadabra, a term used by magicians when doing magic tricks. In the Harry Potter universe, it was used as a killing spell. And it's an unforgivable curse. So you can certainly read more about this. But I wanted to get back. Oh, there's a good picture. Yay, that one came through. They talk about the uses when it was used. Bellatrix Lestrange used it on Sirius Black. And I think they say Harry tried to use it, but it has, in your intention, has a lot to do with it as well. Okay, so, yeah.
And Scott said he loved Beyond 2000. Yep, me too, Scott.
All right, so let's go ahead and move on because, Avada Kedavra. There we go. Why did it do that? It jumped. I thought it would bring us right to the top. You can thank science for these awesome magic tricks. And I kind of like what they say. Is it magic or is it science? Science magic tricks look like magic and in fact with a secret, but that secret is based on a scientific principle, usually something like chemistry or physics or even psychology, like the Ames window. That's more of your brain interpreting, I think, right? Some tricks are actually stunts that are science lessons, while others are tricks that have secrets based on scientific principles. And still others are simply optical illusions or exploit a quirk in mathematics. You can perform these magic tricks as straight out tricks or use them as opportunities to teach scientific concepts. And we'll see a few of these over and over again. If you took a plastic, just a, kind of a just flimsy little straw and used it in a specific way, you could punch it through an object. They say an apple or a potato. And I've seen it done. It's kind of interesting because they'll try it at first, just holding it. And then, do you want to know the trick?
Yeah, you cover the end.
You cover the end. And basically all that air that's in that straw gives it more sturdiness and you can punch through. So we got a comment?
Yeah. Cliff didn't like the Beyond.
It goes right in the place. Yeah, don't tell people
Cliff,
that.
Cliff, that was told to me by someone from Australia, okay?
Yeah. Alrighty. And I think some of these also have, talk about kids. These are kids' tricks, but I think anybody can do it. And the beauty of this site in particular is it gives you the how-to. Hold the straw in your dominant hand, grasp it near the end so you can unobtrusively cap the end with your thumb and trap the air inside. And you might actually want to talk to, here we have an apple. Please hold this solid. You can put your thumb over the end, and then people are paying attention over here when you're performing the sleight of hand somewhere else. Grasp it near the end. Swiftly stab the apple or potato with the straw. Why it works?
It doesn't work so well with a potato.
No?
Unless the potato's really soft.
Ah, okay. You've tried this.
Yes.
I haven't tried this one.
The air compresses enough to let the straw collapse.
I see.
If it's
why it works. See, this is really cool. When it encounters a hard surface, the air gets trapped inside the straw. It stiffens it so you can pierce the flesh. The tube. And I did not understand this one. These might be links to another place that kind of flesh out the details. Yeah, I can see that. But this one, it's talking about a tube. And I guess you pre-stuff it or something. Anyway, I did not understand this very much. Oh, we lost the picture. That's too bad. The bell drop. And I'm like, I really wonder if this is true because they talk about, having someone hold just a regular dollar bill and another person putting their fingers near it but not touching it. And then you drop it and supposedly your reaction time does not exceed the swiftness of gravity pulling on. You tried that?
Oh, yeah.
Have you?
Yep.
I got to try these.
As a kid.
Okay. So I thought that was interesting. Again, they talk about how it works and why it works. So that's cool.
I had a really mean uncle who told me that I could have it if I caught it.
You think that's mean, huh? He's trying to teach you a lesson that you can't grab as fast as gravity can pull. Vanishing water. This one's kind of cool. And I saw a really neat, I don't think I have it here, a really neat experiment where he was like, he poured water in and he switched around the cups. And then he's like, where's the water? Oh, you see it here. Oh, Daniel's here too.
Oh, hey, Daniel.
I guess the surface tension of your thumb is strong.
Well, yeah, the skin of your thumb is pretty strong. And that's the other thing is that if you have an apple with a really strong skin, which means that modern store-bought apples would be hard to do that with.
Oh.
Unless they're soft inside. because modern apples are bred to have a strong skin so that they don't get damaged in shipping.
Got it.
They're not
And
bred for taste.
I think the Mythbusters did certainly because they were trying to could an insect hurt you if it hit you like right here, and I think they gave the pounds per surface in that one, and it was pretty high. It was like 87 pounds. You have to have 87 pounds of thrust before it pierces your skin, even here where your skin is kind of thin.
Right. Yeah. Well,
and your thumb is much denser.
Yeah. That was kind of neat. Yeah, they were trying to prove or disprove the myth that a bug can kill a motorcycle rider.
Ah, okay. You remembered better than I did. So this guy was, twisting these cups around, and in fact, the lady found it the first time. He's like, okay, try this again. He pours it into another cup, does it again, and of course you can kind of follow it. And then he turns the cup over, and the water is gone. We got a comment.
Yeah, and just
love the Mythbusters. Yeah,
yeah,
yeah. That was a pretty fun show. It is surprisingly easy to do this. It's on some of the other ones I've seen, it has the actual compound, the name of the compound. All right, floating metal, and well, I guess this one. Yeah, this one, I have a video of this one, so I'll show you that when we get to it. Floating metal. Does it float? And it can. The Afghan bands. Let's see, which one was this? Oh, something about the Mobius strip. Yeah, Mobius strip. So you make loops out of paper strips and cut them down the center. I really want to see these. I didn't look at every single one of these links, but you certainly can. Okay, so that's that one. Avada Kedavra! Boom! All right, much easier. 17 magical science experiments that will blow your mind. Again, we have some of the same ones. Have you ever wondered how it works? The revolution has captivated audiences for centuries.
Oh, it takes 3 seconds. You see it, and the delay to move is approximately...
Are we talking about the dollar drop?
Yeah, I think so.
Because that one... yeah, it was reaction time is 1.5 seconds, I think, and the drop was 1.4. It was faster, right. Certainly faster.
Right. Yeah, and you get into reaction times in stopping distances for cars too.
Oh.
Because you go a certain amount before your foot can even touch the brake pedal.
Ah, got it. Reaction times, yes. All right, so this one's kind of nice. It has a table of contents. It gives you a quick answer, quick tips and facts, and then some background, and then you get to the 17 mind-blowing magical science experiments. And I think a lot of it is practicing and how to set it up for your audience. And anyway, yeah, so they're not just sleight of hand and misdirection, but I think that definitely has a role. They often involve scientific principles, walking on eggs, bending straws with your mind, and so forth. Practice and presentation are key. Yeah, there it is. To performing magic tricks successfully. Many magic tricks can be performed using everyday objects found around the house. So there you go. It can be a great way to spark interest in science and encourage curiosity. The science behind magic. They may seem like two different, completely different worlds, but they're actually more closely related than you think. And we've talked about how some of the principles are in fact scientific. Chemistry, physics, sometimes it's psychology. Yep, the art of misdirection relies on psychology and the brain's ability to focus on one thing while ignoring all others. Sleight of hand tricks often exploit the brain's tendency to fill in missing information, creating the illusion of objects appearing or disappearing. Physics plays a great role. Gravity, friction, air pressure. They can be manipulated to create seemingly impossible feats. Exactly on cars, yes.
Yeah.
Chemistry is a key player with chemical reactions and properties used to create magical transformations. I got a really long video. I won't play all of it, but there's some really cool stuff in there. I definitely think it's worth looking into. I think that might be it. Yeah, I think that's it. 49 new mesmerizing science experiments to blow your mind. Oh, I got this one here, 29. It's 29 science tricks. All right, so they go into the mystical mustard pack. And yeah, I didn't quite understand this one. I'm going to have to try these. I have to try them to make them really make sense. Fill the water. Open the mustard pack and empty the contents. Add a small amount of baking soda. Okay, so it changes colors because mixing the baking soda and the mustard pack. There's one that was like, don't even open the mustard pack. And I'm like, how does that work? Walking on eggs. Oh, if you had, oh, I like this one too. They have ratings, 8.5 out of 10. This one's not, oh, so that one's like biggie, 9.5 out of 10. At least their rating systems.
Because the whole walking on eggs, you have to do it right.
Yeah. I kind of wonder about this because how do you get them that close together?
Right.
There's one that's got a picture of them in like an egg carton. I'm like, that doesn't seem like they're close enough. But I think you can, well, there's a lot of things like walking on fire. That's the light and frost effect. So, yeah, we got a comment. You can make a beer disappear in seconds? That's pretty fast. So, walking on eggs, and I think also the walking on nails is the same principle. They're just so close together, none of them get the full pressure. And so you can actually manage to walk on eggs. Make sure they're close together, carefully step on them, and distribute your weight evenly. Slowly shift away from one foot to the other.
Right, yeah. So if you do it wrong, yes.
Omelet.
Yes.
All right, quarter catch. This is kind of cool.
That's kind of like the dollar catch.
Well, but you can catch it with your, because if you put it on your elbow and you practice.
Oh, this one.
This is like a centrifugal effect.
Okay,
it kind of sticks to your arm until you grab it with your hand.
Right. Okay, so this isn't the.
Yep, centrifugal. No, well, it is, but the centrifugal force should keep it on your arm. So when you watch magic trick like this, think about what's the physics behind this. What are they? Where's the misdirection? I'll catch them. Sometimes I'll actually see. Oh, I see what happened there. It's actually still in the other hand. You need a quarter and some patience and practice. Place it on your elbow. Position your arm at a 90-degree angle, 90 degrees. Quickly flick your arm down, creating a circular motion as the quarter falls. Catch it with your hand before it hits the ground. Practice, practice, practice. And let's see, they talk about optical illusions. Oh, I think there's some videos in the original version of this. Yeah. Okay. You may have to watch videos for the rest of this. Oh, dry paper. Here's one. This is kind of interesting because you know, if you treat it properly, you can actually put paper into water, pull it out, and it remains dry. This is based on, water, properties of water and surface tension. Use a special solution. You can create a barrier that repels the water. This is true for the sand one too. They'll put it into the water, and you can actually, if you look at it carefully, you can see kind of a silvery sheen. Yeah. So dip the paper in the solution. Make sure it's fully coated. Slowly lower the paper into the water. Watch as it remains dry. Defying the laws of nature. Well, not exactly. Bending straw illusion. Oh, okay. Let's see. This one's a little different than the one with the fruit or potato. Main bending illusions. I get it. I know what this one is. This is when you put a straw into water. What happens? It's because the water refracts the light. So it doesn't actually bend it, but it appears.
It reminds me of the bending pencil.
Oh, just wiggling it fast enough to get that. Is that a refraction thing though, or is that?
No, this is an optical illusion.
Okay. Fill a glass of water. Place the straw in. Look at it from different angles. And it appears to bend. Walk on water. Oh, this one's kind of cool. And this is a weird word. Look at this. Ever dream of walking on water with a non-Newtonian fluid called oobleck? Oobleck? You can make this dream a reality. Oobleck is a mixture of cornstarch and water. And cornstarch and water is a weird thing because you could put your hand in it and it's all liquidy, right? But if you walk on it or slap it, it seems solid. It seems more solid. So this is what do they call it? A semi-solid, right?
Yeah, and basically anything that hits it fast, yeah,
I would suggest running across it instead of just walking across it, because then you get that sort of slapping.
they actually did do that in Mythbusters too.
That's right. Fill the container with water, leaving some space at the top. Slowly add cornstarch, stirring it until you achieve a gooey consistency. Step onto the oobleck and be amazed as it supports your weight. I don't think you want to stand there, though. Walk, run, or jump and experience the magic of this non-Newtonian fluid. Magnetic wand. That was kind of cool. Because I believe you, let's see, is this the one you take a, yeah. Oh, huh. I thought this was the one with, no, they don't, do they explain?
They don't really.
Magnetic wand is, okay, it might be, there might be a link to see it in the original. But I think what the deal is that you take a rod or a simple screwdriver and you can wrap some wires around it and use a battery. So it becomes electromagnet, actually. So, and I think one of the experiments, because one of these talks about, changing it up and doing some actual experiments with it and seeing what happens. Like if you have more wraps around it, does the magnet become stronger? Can you pick up things from a higher distance, a greater distance? Different things like that. But they just call it a magnetic wand. Okay. Yeah. Different things will react differently to a magnet, anything. Diving egg. Now this one I didn't quite get either. Can an egg dive into a glass of water without sinking? Demonstrates the concept of inertia and the relationship between mass and acceleration. You need a hard-boiled egg, a glass of water, and a small piece of cardboard. Yeah, I didn't really understand this. Fill the glass with water, leaving some space at the top. Place the egg on top of the glass, making sure it's balanced. Quickly push the cardboard down into the glass, trapping the egg inside. So, on top of the water?
Yeah, basically float the egg on the water and then.
Will it float if it's a hard-cooked egg? Okay. So, yeah, I'd have to try this. Because I know a raw egg can float. In fact, the more it floats, the older it is because there's an air gap in the egg. And as it dries out, it gets bigger and bigger, and so it will float more. Oh, I think we got a comment.
Yeah, I recall they balanced a London bus on 4 eggs.
What?
To prove the strength of the shell way back.
How'd they manage that? Wow. Yeah, you got video of that. I want to see it.
Probably built up a platform around each egg, drove it up onto it, and then deflated the platform or something, leaving it just on the eggs.
Or removing the...
Yeah.
Okay. Yeah.
I don't know. I don't remember seeing it, but that's how I would do it.
Yeah, I was just thinking, how would you do that? And that's kind of where I went to. All right, disappearing reflection. This one's kind of interesting. If you look in a mirror, of course, you can see your reflection, but can you make it disappear? This one, they, I thought this was, there's another one with like aluminum foil. But this one, you'll need a mirror with a two-way reflective surface. Hold it in front of you. Make sure the reflective side is facing you. Look at your reflection in the mirror and observe it carefully. Slowly tilt the mirror and be amazed as your reflection disappears. Allows the light to pass through from a certain angle. So that's how that one works. But I kind of like the one with the tin foil too. And I think that's up here somewhere. So we'll talk about that soon. Well,
and you can use just regular glass for that if it's dark enough and you've got enough bright light.
Oh.
That's how when we did haunted houses, how we made a ghost effect.
Oh, right. They do that at Disney as well.
Yeah. Where you take a glass sliding door, because that's easy to get.
Got it.
You have an L-shaped room, where the audience is at one side. It's dark. You put the glass at a 45-degree angle in the corner of the L, and then put stuff behind it, like a chair or something that's 3-dimensional. And then the ghost is off the L on this side, out of sight of the audience, but a bright light on them. So they reflect on the slider, but
it doesn't look quite
right. But but
like a mirror. So.
They don't really see the slider because it's dark. Yeah. They don't see the glass. so they see through the glass and see the stuff behind the glass.
Right.
Plus, they see your reflection on it.
Yes.
And that's exactly how they do the dancing ghosts in the haunted mansion too.
Yeah. Yeah, that was pretty interesting.
But yeah, we use that in our haunted house. So
Very cool. I bet you did a lot of fun things in your haunted house.
yes, some of them weren't so fun, but a lot of fun stuff. Yeah.
Okay. Leak-proof baggie, and you may have actually done this one. It's not that hard to do. You basically fill a plastic bag with water, and then you poke something really sharp through it. Basically, the polymer, here it is, the polymers of the bag sort of just keep tight around. Usually it's pencil or a skewer.
Yeah, and until you pull it out, it won't leak. Mm-hmm. Which is why if someone gets stabbed, leave it in until a doctor's around. Same concept.
Yep.
You won't leak as much until
you watch the show. She's like, don't pull it out, don't pull it out, and they pull it out. Yeah. So, seal. Here it is. Seal the baggie, making sure it's tightly closed. Is that part of it with pressure or something? Yeah. Oh, we got a new comment. All right, Zach. Yeah. Thanks for weighing in, and welcome.
Well, no, it's not pressure. It's more like the skin acts as surface tension. It acts like the polymers do and just contracts around.
No, they say seal the baggie, making sure it's tightly closed. I'm wondering if there's a pressure thing involved with that.
Yeah, kind of it's pressure. The other one is you don't want any water in it.
And they say slowly push the sharpened pencils. You could do that with a balloon too. I don't know if you've ever seen that. You slowly push it in. And again, the polymers of the balloon just kind of wrap around the sharp object. Magic water cup. Oh, here's the one. No, this is a different one. This one is, and I've definitely seen this one. You have a glass of water and you fill it to almost to the top, but you leave some space and you put cardboard or paper on it and you flip it over. Then you take your hand away and the cardboard sticks. Why? Because you've created a vacuum in it.
I've heard that you have to have the water all the way up to the top.
No, because that's what makes the vacuum.
Right.
Oh, let's just leave some space. Fill a cup of water, leave some space, place the cardboard or plastic over the mouth, making sure it's tightly sealed. You have to really make sure it's all the way around. Carefully turn it upside down, keep it in place. Slowly remove your hand, and the air pressure outside pushes against the cardboard or plastic, creating a vacuum that holds the water in place.
Oh, okay. That's to hold the cardboard there. Yeah. I was just going off of just no water will leak out. So, okay.
Yeah, you want to hold the cardboard there. And it's a pressure vacuum thing.
And that's why you want the air, because you want the air to be able to compress, and thus the outside air, the bubble in the cup will compress and thus suck the cardboard against the bottle.
Yes.
Kind of like lift on an airplane wings.
Yes. Got it. So, egg in a bottle, and I've seen videos of this, but I've never tried this. And they talk about paper here, but I think you can use it with just a match, right?
Right.
You light a match, you put it in the bottle, you put your egg on top, and as it cools, the egg goes in.
Yep. In fact, it can go in even before it finishes cooling.
Oh.
Because the heat will push air out around the egg.
Huh.
Create a bit of a vacuum. And then as soon as it's not quite as hot as it is now, it just sucks it in really good.
Yeah, it seems like it goes pretty fast.
Yep.
The key is to create a change in air pressure that allows the egg to be sucked into the bottle. Hard-boiled egg. And the one they said to peel the hard-boiled egg.
Yes. No, it has to be.
Okay.
Because it has to be flexible enough to squeeze its way through the neck of the bottle.
Got it.
Now, here's the thing. Now you've got a hard-cooked egg in a bottle.
Inside a bottle. That's got a neck smaller than your...
Yeah, you can't then get it out without breaking the glass, which then gets glass in the hard-cooked egg. So it's really nice if you don't want the bottle or the egg anymore.
Right. Yeah, see here they say light a piece of paper on fire. But I've seen it with a match.
Even a match will do it.
Yeah. Now, I suppose you could... I don't know what to get it out. That'd be the real magic trick, folks. To get the egg back out again. Oh, balloon pop works pretty much the same way as the poking the
Well, I suppose
Bag
if
of
you
water.
put a really thin tube in there, turn it upside down so that the egg presses against the tube in the neck of the bottle, then put pressurized air into the bottle, you can shoot the egg out.
I don't know. Maybe.
Just trying to solve that puzzle, that's all.
Yeah. You'll be working on that all night, I can tell.
Then I'll
So-
be thinking about how to make an egg gun that way.
Oh, God. So very similar concept as before. The polymers of the balloon will wrap around the sharp object.
Mhm.
Not too tight. Hold it steady. Slowly push the needle through the rubber. And I've seen them do it at the end opposite the where you blow the air in.
Mhm.
So it's kind of it's got the
The rubber sticker, yeah.
Yeah, right. Oh, did we have another comment? Or
Oh, Zach.
Oh, yeah.
Yep.
Wait, extract what? Time
Oh,
lithotriptamine? I don't know what that is. All right, so what do we have? Friction fun. Demonstrates the concept of friction and how it can be manipulated to create surprising effects. Well, you can certainly create static with it. Place a piece of paper on a smooth surface. Oh, this is interesting. Hold the coin at one end and slowly pull it, keeping contact with the paper. I guess it's just if you pull the coin fast, it will overcome the friction. But if you pull it slow, it will bring the paper along, and so that it's not going to overcome it. It'll just bring the paper with. Kind of interesting. I hadn't really heard of that before, so that was kind of fun. Floating rocks. Now, see, this one was weird because they don't actually tell you to use pumice stone. I saw another one. I was like, oh, that's what they were talking about, because they did use pumice stone.
oh, yeah.
Fun bit of chemistry. All right, cool. Container filled with water and some rocks. They don't say what kind of rocks. I'm thinking, yeah, I think the rocks are gonna drop to the bottom. But if it's a pumice stone, that's basically full of air.
Right.
They will eventually fill up and sink as well, but initially you can put them on the water and they will float because it is in fact lighter than the water. Is it lighter than the water?
Yeah.
It's
Fun fact.
it's got the air.
Yeah. Fun fact in the Pacific, where there's a lot of volcanic activity,
Okay.
they sailors will sometimes see temporary islands. There's a whole bunch of pumice stones floating on the water
Interesting.
from a recent underwater eruption.
No kidding. That sounds kind of wild. All right, dry erase. And I don't know that they said this one correctly in this. This is mindtrick.com, this website. I'm not sure they really explain this very well. You can bring a drawing to life, combines the art of drawing with the science of static electricity. You perform this by using a dry erase marker on a whiteboard and a piece of fabric. You draw the figure using the dry erase marker, rub the fabric against the whiteboard, creating a static charge. Hold the fabric close to the drawing and be amazed as the figure comes to life. I don't know about that. I've seen where they've put it on water. It's let's see, it's a water tension thing. So not really sure about that one. Oh, we got another comment.
Yeah, Professor Sumner Miller did this for a Cadbury's ad, and 1 second, about 1 million bottles had eggs in them the next day.
Wait, isn't Cadbury's a chocolate egg?
Yeah.
They use a real egg or chocolate egg, Cliff?
No, he probably used a real egg just as part of the ad, and yes.
And they do have a frequently asked questions segment here. What kind of science or magic tricks? What is that? Sounds cool. Read more about what is Jedi mind control. What science experiment went horribly wrong? Chernobyl definitely went very wrong. Is there science behind magic? Yes. Biggest science experiment of all time. Oh, Large Hadron Collider. So they actually talk about some really cool science projects out there as well. Conclusion. Magic and science go hand in hand. It's not just about sleight of hand and misdirection. It's also about understanding the scientific principles that create these illusions. From walking on eggs and bending straws with your mind, these magical science experiments will leave you in awe and inspire you to explore the fascinating world of science. So go ahead, check it out. All right. Avada Kedavra. Whoops, I hit the button. All right, so I think some of these are the same as the other ones. I won't go into too much, but You can look at rediscoveredfamilies.com, 11 magical science experiments there, and you will find these 36 magical science experiments. And I think I just really did a search on science magic, and I found all kinds of things. And I don't have all of them here to show you, but I do have quite a few of them. They say they're for kids. I think everybody will have fun with them. Hey, we got a picture out of it. That's cool. And it's fun because this person created a Harry Potter event for tweens. And they had a lot of fun. So science can be really fun. Yeah.
Oh,
where are they?
Zach again.
Oh, hi.
Hey, internet feller here. You will never go anywhere you're...
Okay.
Okay.
I think we're being spoofed, spam, whatever.
Trolled. Yeah.
Trolled.
Whatever.
Okay. Yeah. Live long and prosper.
Yeah. And goodbye.
This was, I thought this was something different. Magic Rainbow Rocks. Oh, I guess it's just sort of a curated list of different things you can look for. And they're going to be at the, when you click on the link.
Yeah.
Watch gummy worms come alive. If you don't have gummy worms, you can use raisins.
You can
Baking
use
soda vinegar.
real worms and really freak out the kids.
Worms have 5 hearts. I just found that out recently. Isn't that weird? Baking soda and vinegar. You've probably seen that with the science project volcanoes, what the kids would do. Magic Rainbow Rocks. I think it's a similar thing. But what did I put? Food coloring in or something? A bubbling lava lamp. I think that's kind of an interesting idea. Elephant toothpaste. I've seen these, but I've never done this one. Turn around pan of baking soda into a vibrant globe. And I have a feeling we've got some video on that, especially in the original. All right, I'm going to go ahead and move on because, oh, look, you can subscribe for a free printable from her. So I'm going to go ahead and do that. This field is mandatory. I filled it in. Oh, I accept. Okay. I got a couple of these, so I just thought I'd show you in front. All right, so this one here, and I'm not going to play the sound. This actually is a really cool video in a lot of ways, but most of these you have no idea what the heck it's about. You watch it and it seems cool, and you can kind of figure it out in most cases, but in some cases, like, what the heck did they just do? 5-minute magic is 5-minute crafts is pretty popular, but I'm going to run this one because I think it's very easy to do at home and it's very interesting. There's actually 2 that are kind of similar. They just have a little different idea behind them.
Are those magnets?
That's the end of the previous one. I'm going to run the next one with, yeah, those are magnets, definitely. With red cabbage. So you take the red cabbage, you blend it up, in this case, and you add it to different things. Sprite, soda, sugar. Look what happens. Vinegar. Plain water is going to look the same. Every single one of these things gives you a different effect, a different outcome. And this one here is a little bit similar, but they boil the cabbage in this case, and they use the water. And it's just music, so you're not missing out on the sound in any way, shape, or form, because they don't explain a damn thing on this whole bloody thing. It's really unfortunate. And they use some similar items. They start off this time with cabbage water and add, in this case, the lemon juice, baking soda. And I think that, yeah, they show you the different colors. And vinegar is a lot like the lemon because they are both acidic.
Yeah.
Acidic. All right, and here's the surface tension one. Remember we talked about, yeah, we got a comment, yeah. Yeah, I know, right? The dry erase and fabric trick. I'd have to play with it, and I've learned something, especially doing crafts. Almost inevitably, the directions are somewhat
lacking.
That's a very nice way to say that. And you sit there and go, no way, there's no way you could do that. And then you're like, all right, I think I know what's going on here. And I'm just so tempted to rewrite all of the craft, everything in the whole world to make them right. But that's another lifetime's mission. All right, this is in a foreign language, but the words at the bottom, we have here these 2 petri dishes. You will see, you can in fact understand it because of the closed caption. All right, so you want to bigify this? It's kind of interesting. I want to watch this. This is the metal in the water tension. Surface
Tenemos aquí
tension.
estos dos pequeños recipientes. En uno de ellos voy a poner agua y en el otro alcohol etílico, también llamado etanol. Simplemente dejándola caer de plano, la cuchilla se sujeta sobre la superficie del agua. Ahora vamos a intentar lo mismo sobre el etanol. Directamente se hunde. Voy a probar con más cuidado. Nada. La débil tensión superficial del alcohol no es capaz de sujetar la cuchilla. Ahora voy a poner unas gotas de alcohol a ver qué pasa. La cuchilla se hunde al disminuir la tensión superficial.
Why take less when you can get a beefy?
And yeah, they were all talking all surface tension. Didn't have anything to do about density or anything. It was just all surface tension, and the alcohol broke the surface tension.
Well, yeah, I thought it was interesting too. Well, the two things: the alcohol, you couldn't lay the metal onto it,
Right, it doesn't have the surface tension.
right? And then adding alcohol to the water, you say it broke the surface tension.
Yeah, it basically chemically gets in there because the surface tension is, the water molecules aren't really stuck together, but they will form a lattice on the surface because they're all trying to stick to everything, but the ones on the very surface don't have up to stick to.
Yeah.
So they basically have to stick harder to the things around them. So the top layer has a higher stickiness than the rest of it, just because of the way it works. Basically electromagnetically.
Okay. And here's an interesting thought, because of course, water tension, when they release water into the space station, when they have microgravity, it forms a sphere, right? So what does alcohol do? Does it just wiggle around?
It still forms a sphere.
It does,
but it'll break up easier. Whereas like with a water drop, they can bat it somewhat and just move it around. But if you hit it too hard, it'll break up into small dots. With alcohol, it just takes less force to do that.
Okay.
And also, it's more likely to stick to your hand rather than stay a ball.
Yeah, that's what does it do? It wicks.
Yeah.
It wicks onto your.
Right. But the thing is that the surface tension isn't as high, so it's just more likely to, to soak into whatever it touches.
Okay. And in the event that you have not seen sodium in water, what did Cliff say?
Cliff saw the image and knew exactly what was coming.
Yeah, and this one, I'm a little surprised about this. But anyway, in case you have not seen how sodium reacts in water, I found a video on it. Here we go.
We'll go down the column on the periodic table in group 1 and look at sodium. Like the lithium, the sodium is stored in a mineral oil to minimize reaction with the oxygen in the air. If we remove a piece of sodium metal, we notice that it's also coated up.
You notice he said like lithium. This is why lithium batteries catch on fire. If they get popped and air gets into there, it can react. Now, it reacts more with other parts inside the battery.
Well, water.
But so, yeah.
And it's interesting, too. I saw one that had like the lithium, the sodium, and was it potassium?
I think so.
And each one had a much more active reaction.
Right, yeah.
Depending on. All right, so can we go on?
Yeah.
All righty. I really love this. It shows you the metal. Anyway, you'll see.
With an oxide coating. Group 1 metals become softer as you go down the column. The sodium is much easier to cut than the lithium. As we cut off the oxide layer, we can see the shiny metal underneath. It coats over very rapidly with a layer of oxide. The sodium is a metal and is an excellent conductor of electricity.
I did not know that.
If we take a piece of the sodium metal and add it to water, we notice a much more rapid reaction with the water. Like lithium, the sodium is less dense in water and floats. The metal moves across the surface, being pushed by the hydrogen gas that is produced. As you go down the column with group 1 metals, the melting point of the metal decreases. The reaction is very exothermic, which causes the sodium metal to melt. The metal contracts into a very compact spherical form. We can again test that hydrogen gas is being produced by this single displacement reaction by trapping the gas and testing its flammability. We can test for the fact that we produce sodium hydroxide by adding phenolphthalein. The phenolphthalein turns a purple-red color due to the presence of the hydroxide ions, indicating the formation of the sodium hydroxide.
Okay.
I
Daniel,
love that. 3 experiments in one. Yay.
Daniel says there are 6 alkaline metals: lithium, sodium, potassium, rubium, cesium, francium, and francium. They're located in group 1, the leftmost column of the periodic table. Yep.
Awesome. Thank you for that, Daniel. Very much appreciated.
And as sodium, a buddy tells me about one time when they had a new science teacher
Oh boy.
who decided to clean out
Oh yeah, you told me about
his closet of materials and found a
boy,
brick
no.
of metal and just tossed it outside in the trash bin, which high schools here, I don't know about other places, but high schools here often use 50-gallon drums, oil drums as their trash bins. Well, it had been raining not too long before he did this. And so he said that it created like a perfect smoke ring from that.
I bet. I just had to include this because, wow, this looks amazing in action. And you'll see why. You'll see what happens here and why.
Mercury forms alloys with most metals in a process known as amalgamation. Last week, I messed around and tested it out with some gold leaf, and it was pretty cool. This time, though, I'm going to see what happens when I add it to aluminum. It's supposed to be quite destructive, which is why you're not allowed bringing mercury on a plane. So I went to Home Depot and I bought a strip of aluminum. I cut out a small section and drilled a hole about halfway through. This little crater is important because mercury is super annoying, and without it, it would just slide off the plate. Under normal conditions, aluminum is surrounded by a protective oxide layer. Metallic mercury isn't able to penetrate through this barrier, so it kind of does nothing. Sometimes it's possible to get things going by manually scratching away the oxide layer. I tried doing this about 2 or 3 times, but it wasn't working for me. I even tried to brute force things using a drill, but that didn't get things going either. I thought that maybe it was just super slow to get started, so I went to lunch and I left it for about an hour.
This is the new Brookside home of
an
Jeff
ad.
and Dan. In their old home, the playroom was upstairs.
One time while I was cooking dinner.
When I came back, nothing had changed, so clearly I have to use a different strategy. Instead of trying to remove the oxide layer mechanically, I'm going to try to do it chemically. So I took out all the mercury and I added some dilute hydrochloric acid. The hydrochloric acid quickly reacts with the oxide layer and dissolves it away. This exposes fresh aluminum metal, which also reacts with the acid. I let it go for about a minute, and then I get rid of the acid. With the acid gone, we'll start to reform the oxide layer, so it's important to add the mercury quickly. The amalgamation started almost right away, but it's really hard to see. In the reflection, you can see me lean over to get a better look, and I notice some very small hairs forming between the aluminum and the mercury. In real time, this process is really slow, so I set things up for a time lapse. So the major thing going on here is the combination of the mercury with the aluminum to form the amalgam. Some of the amalgam that forms gets dissolved in the mercury and makes its way to the top. When it gets there, it comes in contact with oxygen in the air, and it reacts to form white aluminum oxide. This part of the process is pretty short-lived though, because it quickly gets covered and protected by the oxide. This prevents fibers from growing directly from the mercury, but obviously they continue going out from the sides. This happens because some of the mercury is dissolving into the aluminum. The amalgam here also reacts with air to form the oxide, but the difference is that it doesn't shut itself down. The dissolved mercury can continue to creep along the surface and amalgamate more aluminum. In theory, this process should keep going until the entire surface is covered with a thick layer of the oxide. The mercury could also penetrate deeper into the aluminum and compromise its strength, but I think that takes a really long time to do. About 4 hours later, I decided to end the time lapse. I spun the thing around, and when I noticed the other side looked a lot cooler, I was a little bit sad. Anyway, when I poke at it, you can see that it's not structurally very strong. I'm not sure what I was expecting, but I was surprised at how fragile it was. It looks like there's quite a bit of aluminum oxide here, but surprisingly, there's only about 200 milligrams. I went to clean things up a little, so I scraped away a lot of the oxide. On the edges, this reveals fresh aluminum amalgam, which is the silver stuff that you see. As usual though, it quickly reacts and turns gray again. As I said before, some of the mercury has dissolved into the aluminum. I was really curious to see how much more amalgamation would occur if I took away all the visible mercury. So I removed the large drop and I cleaned things up. I then left it out and did another time lapse over the course of a couple hours.
Wow.
There was apparently enough left to get a decent amalgamation going, but it was actually less than I was expecting. I cleaned things up again, and this time when I scraped the edges, they're not silver like before. Clearly the amalgamation process is done. I think the reason that it stops is because all the mercury that's present is amalgamated with aluminum, but it's hidden under the oxide layer. Without the main drop in the middle, we don't have excess mercury to creep out and continue making more amalgam. It also might be possible that small amounts of mercury are taken away as the fibers grow, but I don't know if that actually happens. Anyway, I'm going to go ahead and react things again.
I just think that's really interesting how it grows. And there's a couple other things that react like that. There's a little tablet they burn, and it just makes this big snake thing. A lot of the fireworks displays are related to that too. We had a couple comments I noticed.
Cliff, talking about the sodium trick, and then it's talking about there are videos of chucking a huge block of sodium into a lake and it explodes very, very violently. Yeah, I think the saving grace for that high school was that there wasn't a lot of water in that barrel, and I think the initial explosion just basically blew it out as water vapor and thus stopped the reaction. And then and he's talking about the ads there. YouTube Premium, $5 a month for no ads.
Okay.
And and the aluminum.
You see, okay.
Yeah.
So this one here has the three. I'll just run it.
Three metals.
Yeah.
Here I'm working with some lithium metal, very difficult to cut. I've got a piece of sodium here, pretty easy to cut. You notice my lithium hydroxide. So you're going to see a pink color develop.
And this looks like to me like he's put these in a hood so that this
Yeah, you can hear the fan of the hood.
Right, and it kind of looks like.
Yeah.
This is to make sure it doesn't escape into the atmosphere.
Right. Well, and the whole thing of bubbling off the hydrogen, and it's because water is not tightly bound. The water molecules aren't tightly bound. So it's the lithium is grabbing the oxygen, and that's what's burning, and it's freeing up the hydrogen.
We've got some comments. We lost sound. Huh.
Oh.
Okay. Oh, you know what? Okay, I understand what happened. Okay, thank you for letting me know. I'm gonna go back just a little bit. Okay, because he cut up all these 3 different ones, and he's gonna put them all in water. Yeah, go ahead, Daniel's got a comment. Yep, sorry, that was me. Yeah, last metal potassium. Like I said, I'm going back a little bit so you can hear the whole thing.
Especially with the potassium here, I'm going to go ahead and give this kind of a half cut.
Potassium.
So for the potassium, this is the side that's been freshly cut, and you can see the dullness to the other sides compared to that one. So I'm going to go ahead and take those 3, and I'm going to add them to water, and we can look at the kind of reactivity of those 3 alkali metals with water. So here I'm going to take the lithium and add that to the water. It's going to generate hydrogen gas and lithium hydroxide. So you're going to see a pink color develop here, and then you're going to see some smoke come off, and that's either lithium metal or that's lithium hydroxide coming off of there. Maybe a little bit of liquid water. But it's not as reactive as, say, sodium. So I'm going to put sodium into the next one. And the sodium is actually probably going to ignite.
That's more like what I was
So
expecting.
you'll see some orange flame, perhaps, or some sparks, or some shrapnel. And then the last one, I'm going to go ahead and put my 2 pieces of potassium in. So that cut in half. So this is less potassium than the other 2 in terms of amount. You'll find that the reactivity is a little bit greater.
Much more exciting.
I know which one should have had the cover on it.
Yeah.
It's done, I think.
Now that potassium there was quite reactive there, but the sodium sometimes will allow hydrogen gas to build up. In this case, it's not igniting. But we can try adding another piece here. And we can hope that that's going to go ahead and actually send off some shrapnel.
No, that's sodium again.
No, that's lithium.
Oh, I thought you said it was sodium.
Oh, no. That first one's lithium because he's doing it by molecular weight. Lithium, sodium, potassium.
All 3 produce hydrogen gas. All 3 produce hydroxides.
They really react to water.
Mm-hmm.
All right, so I think I have a couple more things here for you. Yes. All right, and this one doesn't really need to be moved because there's really no ads on this one. Sciencefun.org. Lots of cool experiments, and it's a little different format. We've talked about a bunch of these dry paper, quarter catch, walking on eggs. This mustard one is a little different. Oh, and I love this picture about the bending straw illusion. Walking on water, we talked about that one. Magnetic wand, and that's why I was saying they actually mentioned the wires wrapped around. In this case, it's a screwdriver. Diving egg, I think it's a little more understandable, but this one's possibly done a little bit better for kids, especially. Here's the one, disappearing reflection. They say if you take carefully some aluminum foil, you can pretty much still see your reflection in it.
Mm-hmm.
But let's say you bunch it up and then you try and flatten it out again, your reflection is gone. And that's because all these little bends in there have just dispersed the reflection.
Mm-hmm.
It's no longer like right directly to you.
Right, yeah.
There's the leak-proof bag, magic water cup. Yeah, that's the one with the the pressure.
Mm-hmm.
Keeps the cardboard on the bottom. Egg in the bottle. And see, here's the dry erase one. I think that one makes more sense. Fabulous floating rocks. This is pretty cool. They talk about friction here, balloon, and that's it. So this one is sciencefun.org, and I believe you go to the Kids Zone Science Experiments. Yep, there it is. All right, what else do we have? 5 amazing magic tricks you can. Well, let's get rid of the ads. Avada Kedavra. There you go. I think a lot of these are the same too, but it's really nice to have a variety of ways to see.
Yeah, because there's different ways of explaining things, and people have different ways of learning. So
yeah, like this one I thought was a little bit better in a lot of cases. Oh, here it is. I think this is the sodium. Here, I think this is that compound they put into the cup to absorb the water. Sodium polyacrylate. And magicians actually do use these things in their tricks. It's a hygroscopic substance.
Yeah,
absorbs water.
It's like those packets you get in items that ship to you.
Baby diapers. They say baby diapers has this.
I hand them to people and call them flavor packets.
Yeah. Yeah, I think it's a slightly different thing. But it's probably hygroscopic as well.
Yeah.
All right. Burning money. And this one, burn your bill. Oh, but here it is. It's just fine. Well, I guess you use a little bit of alcohol, which I love this part. Again, the science. Also read how does it. So they give you other options as well. It's basically been doused in alcohol water mixture, and so when it's lit, it's the alcohol that burns, but it's not very hot, so your bill remains. So pretty cool stuff. Traveling flame trick. Oh, I've never really done this one, but I think it'd be really good. And does this one explain why? Because I guess some of the wax, when you blow out a candle, some of the wax is still dissipating into the
right. It's the vapors.
The vapors.
Because
right.
Generally it's not the wax that burns; it's the vapors of the wax.
That
burn.
Okay. And so if you relight it somewhat above, the wick will catch fire again. That's what that was about.
It's hot enough that the wick will light it up again. And that's trick candles too. They have thin wires of magnesium to keep them hot enough that when you blow them out, it's hot enough to relight itself.
Oh, I didn't know that. There's a little science magic for you. This one, I do not think you could do this one at home because they talk about things like, where is it here? Superconductors. That's a little more scientific lab kind of trick. Thunder in a bottle. Sugar. They take sugar and put them in a transparent jar. Then they ask the audience to turn off a light, and then they hammer.
Yep.
They hammer the crystals next to it, and they kind of light up. Kind of interesting. I think there's a picture of this, maybe on and you can go back, just so you know, you can go back to the previous page. Let's see if we go. There's the hygroscopic material. Burning money.
And they talk about the trick in the science.
Oh, there's the lighting the wick again. Yeah, it's unfortunately when you go to that other view, you kind of miss some things. Yeah, see, like this, there's no way you're doing that at home. I don't think. I do like the wee though. Thunder bottle. Yeah, here's a good picture of it. It's kind of a GIF, I think, Jeff. So they're hammering it, but it appears like a lightning.
Yep.
The science, the sugar-like crystals are actually a compound called europium tetracus. This is a sugar-like substance at room temperature. The most interesting thing is that when they disintegrate, they convert kinetic energy from the hammer directly into light energy. So there's a bit of chemistry involved in that one. What else do we have here? Oh, I think that's it. All right. And so, it just keeps going. And this is a pretty good one. There's no real ads. Vanishing water. We've seen that. Foaming rainbow. We kind of know about that. Floating metal. Disappearing coin. I think that one's a little different. Refraction. Oh, this one might be like the bending straw one. You can see it from some angles, but not others. I think we got another. Yeah, lightning, not thunder.
Yep.
Maybe. I don't know. And I think that's it for that one. Then the
Cliff is flavor packets. Yeah, new guys at work,
always get some.
open a product, flavor packet, and I get the strangest looks at work. I don't know why.
Don't eat the flavor packet in that. I'm almost done here.
That's
so
not what I say. I say, do you want the
I've
flavor
heard
packet?
I have heard you say the other. So I found a really cool website about the Science of Magic Association, SOMA. They have a conference coming up.
I only say
archive.
I only say don't eat the flavor packet if I think that they're stupid enough to actually do it.
Science of Magic Association promotes rigorous research directed toward understanding the nature, function, and underlying mechanisms of science. Provides a platform of discussion and dissemination of research and ideas on magic. It's an inclusive organization that welcomes members with diverse backgrounds, yada yada. And there's a neat video. I'm not going to play this one. I think you should go there. This is Science of Magic ASSOC.org. They talk about different research projects. And the interest has gone. This is cool. Since the year 2000, the body of experimental scientific literature on the topic of performing magic has continued to rise dramatically. To date, 109 empirical papers have been published on the topic of adult perceptions of magic tricks within the last 20 years, compared to the 12 that were published in the preceding century. Between 1887 and 1999. The idea of investigating the psychology of magic is not new. Indeed, it arguably dates back to the earliest days of experimental psychology, but this recent level of interest is historically unprecedented, and they have a graph. You can find some of them in open access articles, and they got a conference coming up in Las Vegas, Nevada. It's going to be later this year, November 12th. And 13th. It's the 4th biannual. So what? 8 years of it now?
Mm-hmm.
4 of them. 8 years. Teller's going to be there, and he's going to talk. He's the guest of honor. And some of these other people, I do not know who they are. Professor Thalia Goldstein, Carissa Hendricks, Professor Chris Go-To Jones. Special symposium with Jeff McBride and the Magic and Mystery School. Click the button below for the full list of confirmed presentation abstracts. Full schedule coming soon. And I opened up a couple, I got some past events. But I opened up a couple of other things like the newsletter archive. You can see those there. And you can get a newsletter. You can get the newsletter. So I'm going to go ahead and subscribe to that too. Okay, that's cool. And what do we have here? Registration for the conference. And it's pretty reasonable. $250 goes up to $300 after tomorrow. So if you want to do that, go soon. All right, and this was the really big one, 40 science experiments you could do at home. I don't think there's any real instructions on this too, but there's some cool stuff in there. I've seen it all. Did we get another convert?
Nope. Oh, yeah.
I thought so. So I could see out of the corner of my eye.
Cliff, I know some people that would. It's a bit chewy though. Yeah.
He's talking about the flavor packets.
Yes, I know. I mean, there are some people that I'm like thinking, one comment from me and Darwin will take effect. And it's like, do I do the world a favor?
Oh boy.
Or do I not go to jail?
I know this is pretty cool too. You can separate alcohol and water. It just takes a little salt. And they added in some coloring so you could actually see them. And I'm going to go ahead and end with this. And above all, watch with glittering eyes the whole world around you, because the greatest secrets are always hidden in the most unlikely places. Those who don't believe in magic will never find it. Roald Dahl. And he wrote all the Charlie and the Chocolate Factory and
a lot of stuff.
All kinds of other things. Go ahead and bring it back to us.
Okay. There you go.
Where are we? So the question is it possible to be the technomage of Babylon 5 lore? I think it might be. And I don't know if you've ever seen that out there, folks, but they do have one brief shot, and I think it's Galen, who is in the medical bay or something, and he's got like chips in his back. Like they're surgically embedded. So
Yep.
the techno mages, they can, perform magic tricks that they can perform scientific things that look like magic. They'll click their fingers and something will happen. But that's kind of around, sort of. But they're sort of what are they? They're like Soma. They're a group. What do they call them? Do they have a group name?
I don't know. They're emo tech guys.
Well, let's go ahead with the stellar events this week, Jeff. Yowza.
Okay, some stellar events this week. August 16th through August 23rd.
You got this?
Yeah.
Okay.
August 17th, Pluto and the Moon are in conjunction. August 18th, Mercury is in inferior conjunction. August 19th is a full sturgeon moon.
It's a fish.
Yeah. Yeah, I wonder
It's a fishy moon.
if you can get caviar from it.
It's not made of cheese.
August 20th, Saturn and the Moon are in conjunction, and Saturn is 0.4 degrees south of the Moon. An occultation is visible from Central America and most of Europe, and probably over a good chunk of the Atlantic.
Probably, yeah.
August 21st, the Moon is on the equator, and it's at perigee. And Neptune and the Moon are in conjunction, which means that Neptune is pretty darn close to the equator, too.
Yes.
August 22nd, the Moon is an ascending node. August 23rd is a Friday night show and a crunchy topic. So we know that you like them.
We know you like them.
Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel.
What inspires you the most for the coming week?
Okay, here's Cliff with one of his magic tricks. Alcohol, salt, and lime is perfect.
That sounds like a margarita. Anything else from you?
Nope.
We'll watch for your comments going forward. But if you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share live. Join us again next Friday, August the 23rd. And the crunchy topic is fusion. We've discussed fusion in some of our past episodes because it's what stars do.
I just remembered what I wanted to talk about.
Oh, boy. Yes.
And
then share. When you're done with that, share the screen.
Okay. Just, we talked about Harry Potter there, and we're talking about science, and, you were talking about the abracadabra, whatever that is. There's a fanfic called Harry Potter and the Methods of Rationality. Just look for Harry Potter and the Methods of Rationality. It's basically if Harry Potter went into it with a scientific mindset. It's actually really, really good. And it solves a lot of the things that I didn't like about the series.
Okay. So I'm going to go ahead and show you
Did you show Janie's?
Oh, yeah, not yet. Go ahead. Fun fusion.
Yep.
Yes. We've done this a bunch of times because, and let's see, I'll go there quick. And you can put in the word fusion, and you can actually do this for anything, anywhere. If I could just spell it right. And what'll come up is any of the episodes that fusion is involved with. And as you can see, we've done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 40, like almost 20 of these. And almost 20 episodes.
Yeah, well, because fusion comes up a lot when we're talking about space stuff, because all the stars have fusion involved.
Right. So next week, we're actually going to talk about what fusion is and the current state of fusion.
Yeah, you guys in the names of full moons. I think he's talking about Americans in general, but yeah.
Well, I mean, some of those were from the American Indians, so we don't name our moons. Well, you see it upside down, so that makes sense. Let's do a shout out for people. Cliff and Janie and Daniel was here and Zach was here. Thanks for showing up, Zach, for the first time. Scott. I know Dawn was here. Did we miss anybody? Daniel. I got Daniel again. Zach. I think that's it. You are a wonderful audience as usual and so very helpful with all the facts and figures and research that we just don't have time to do while we're here. So, yeah, have a great week and we'll see you next Friday. Good night.
Good night.